Hello, good morning, dear students. I am here again back. I'm Dr. Paresh Rawat. I am here again back with our second session over the cognitive radios. In the first lecture, previous lecture, we have discussed about what actually is the cognitive radio can do it. So here we will be discussing about the types of cognitive radios. As in the previous lecture, we have already discussed what and cognitive radio can do. We have discussed that the most of the part of the radio spectrum is not fully utilized. As you can see here by the thumb, that the parts by the thumb which are being there are not properly actually been utilized. It is only these parts of the network which is actually utilized. Most of the part of the network is unutilized. So what actually CR does, the cognitive radio is licensed to the primary users only, and like cellular providers, we are actually running out of the space. Therefore the cognitive radios allows us to use the vacant space of the spectrums. Now, what are the types of cognitive radios? As you can see here, there are three basic types of the cognitive radios. One is underlay cognitive radios, overlay cognitive radios, interweave cognitive radios. We will be discussing about these three different types of the cognitive radio systems one by one. Now, how does we have classified these three different types of cognitive radios? That depends upon how the cognitive radio, that is your secondary users, will actually access the system with primary users. So based on the access and the permission allowed, the cognitive radio users will do it. Okay, so the next is, first part is underlay cognitive radio systems. What are the underlay cognitive radio systems? During the underlay cognitive radio spectrums, the primary users, which may be your cellular providers, which are actually using the spectrum, and the secondary users, which are actually nothing but which are the cognitive radio CRs, will be using the same spectrum at the same time. But okay, so that means underlay pentagram allows for simultaneous secondary and primary transmission. The underlay pentagram allows for simultaneous secondary and primary transmission. This is my underlay system. Now, how does it take place? To ensure that primary user is protected from the secondary user, the secondary users may not cross the imposed interference noise label within while the primary user is ideal. That means even when the primary user networks are free and there are spectral holes in the system, then also we have to assure that secondary users does not go beyond a certain level of power or certain level of noise. That means the noise level of the secondary users are limited, although they are utilizing the spectrum simultaneously, but they cannot cross a certain limit. The secondary users must therefore know the aggregated interference from the secondary transmitter to the primary receiver. Okay, so in underlay systems, it is mandatory that secondary users must first know the amount of interference over the primary user by the secondary users. Okay, so there are three things. First thing, in underlay systems, both will use the system simultaneous transmissions. Secondly, secondary user has to ensure that their noise level does not go beyond a certain level. Third thing, the secondary users must ensure that how much amount of interference is actually being imposed over the primary user by them. So this is basically the system called underlay systems. Now, what is overlay systems? In overlay system pentagram, the similarity to the underlay allows for coexistence between the secondary and primary users in the same band. That means in this system also both primary and secondary users can simultaneously transmit the data. in this scheme, there is no power limit for the secondary transmission. In the other words, there is no limit of interference. Primary and secondary users both can transmit simultaneously, but secondary users can transmit with a maximum power level. But in order to assure that, to avoid the conflict between primary users and the secondary users, it is assumed to have certain knowledge about the primary transmissions parameters, which is known as codebook. That means in overlay pentagram, both can simultaneously transmit. Secondary user does not having any limit of power. They can transmit with their maximum capacity of the power with primary users, but secondary users uses certain information about the primary users in terms of certain code books. That means in certain codes, in terms of certain codes. Okay, so that is what the overlay system. Now the third one is the most important one, which in terms of the cognitive radio diagrams, that is interweaves. It was the first original sharing technique. It was the first original sharing technique proposed for cognitive radios. Okay, so that means in this interweave system, primary and secondary users, that means secondary user will share the same spectrum of the primary user based on spectrum sharing basis. That means it is not allowed to transmit both the users simultaneously at the same time, but secondary users will transmit depending upon the ideal part by utilizing the ideal part of the primary user. That means when primary user is free to transmit, spectrum holes will be identified, and then based on the spectral holes, the secondary users will be using their services. Okay, now secondary users may access licensed frequencies only if the primary user is not transmitting. That means if the primary user is ideal. Now secondary users uses sensing techniques to detect primary users signals and can opportunistically access the ideal band. That means whenever the spectrum of the primary user is free, that means ideal, they will be using those probabilities of free spectrums which varies with time for the transmission. That means there is no certain pattern of transmissions. We have to use probabilistic approach. Secondary users will use the probability of spectral holes for the transmission. Okay, so that is basically very important part, okay, of the cognitive radios. Now let us try to compare what actually is happening with overlay and underlay systems. Now I have a scheme here. In the system, in the comparison diagram, you can see this comparison diagram over here. We will be using this comparison diagram. Now on the vertical axis, you can see it is your power spectral density, and on the horizontal axis it is your time, frequency. So that means the band of the system. Now the power spectral densities, the blue curves are the power spectral density of the primary users, as you can see with the thumb, and the red part, which is equally spread over the system, is nothing but it is the underlay transmission by secondary users, that is UWBs, okay, ultra wideband system. So it is an underlay ultra wideband transmission system. Now you can see here, as we have discussed, that during the underlay system, primary user and secondary users, both primary users and secondary users both are transmitting simultaneously, and the noise level of the secondary user does not cross a certain limit. Now what is the limit? The limit is shown by this basic black label. Now this black label is the power spectral density mask. So that means the power spectral density of the second user does not crosses this limit. Okay. Now let us compare what actually is happening in overlay systems. In overlay systems, primary user and secondary users are simultaneously transmitting the spectrum, because blue one is the primary user, red one is the secondary users. This is the secondary users. What is the secondary user? It is overlay cognitive radio transmission. Okay, it is overlay cognitive radio transmission. Now in this case, the primary users and secondary users are transmitting simultaneously. There is no power limit of secondary users. Secondary users can transmit with their maximum power limit. Secondary users can transmit with their maximum power limits. But the only constraint here is that secondary users must use certain code book about the primary users information. Okay, so that is the basically overlay system. Now let us compare what is actually happening for all three systems together. Now interweave also comes together here. Let us first discuss overlay system. In overlay scheme, now you can see here that is your power spectral density. This is your time, and on horizontal axis it is frequency. So it is time frequency curve and the power utilization. Now here you can see that the primary user and the second user both are simultaneously accessing the system. They are accessing for the entire time. Okay, they are accessing for the entire time. Only thing is the secondary users must not cross a certain level of transmissions. Okay, so it is not mandatory. Primary user is always there, which is this one. Secondary users uses the spectrum whenever it is required. They can transmit simultaneously. Now in another part also, in underlay system, it is also the same. Now this is primary users, this is your cognitive radios. Now the primary user can transmit the spectrum simultaneously, but in underlay system the secondary users these are the cognitive radios. Now cognitive radios and primary users can simultaneously transmit the spectrum here. Similarly in here the cognitive radios and primary users are simultaneously transmitting the spectrum. Only thing is the power level, so they can transmit with the maximum power. Okay, in the third one, that is interweave system. Now in interweave system they cannot transmit simultaneously. This is your primary user, okay, and this is your secondary user. So the primary user and secondary users cannot transmit simultaneously. Either it is a primary user, either it is a secondary user. The primary user or the secondary user. Secondary users are identifying the spectral holes and then they are transmitting based on the spectral holes. That means there was a spectral hole here. There was a spectral hole here. Okay. So since in case 1 at a particular time t1 there was a full spectrum utilization by the primary user, so here if you can see that in interleave systems there is no secondary user because the entire spectrum is actually occupied by the primary user. In second case there was a hole here, the primary user is having a hole at this part, so you can compare here the in interleave systems it is primary user, then this is a spectral hole, the secondary user and then the primary user. Similarly if you compare here in the case 3 the primary user was using the spectrum for a small duration, so there were two holes. This is hole 1, this is hole 2, and you can see here it is cognitive radio utilizing hole 1, it is primary user, cognitive radio utilizing hole 2, and it is the primary user. So I think this concept is very clear to you all. Okay, so let us begin with another concept which is called as spectrum sensing. Dear friends, as we have already discussed, there are many holes, areas, regions available for the spectrums. The spectrum is not fully utilized. So what is spectrum sensing? Spectrum sensing is a technique to sense the spectral holes in the system network. By sensing the and adapting to the environment, a cognitive radio is able to fill in the spectral holes and save its users without causing harmful interference to use the licensed user. Okay, so that means by sensing the and adapting to the environment, a cognitive radio is able to fill in spectral holes, that means whatever the holes are there when primary user is ideal, and serve its users without causing any interference to the primary licensed user. Licensed user is nothing but it's a primary user. Now you can see here these black nodes are the nodes of the primary users. Now here this circle, this entire circle which we are having is nothing but it is a one particular cell area or a cluster. These clusters is nothing but there is a primary user available on the cluster. Okay, now these primary services, these are the cognitive radios which are installed in the network. These are the CRs, these CR1, CR2, CR3, CR4. These are the 4 different cognitive radios which are installed. Nodes are installed within the same network. Now this is a common receiver. Okay, now this common receiver can receive from all these different cognitive radios. Now primary user, even the primary user is transmitting through the cognitive radio networks. Okay, or cognitive radios can transmit directly to the receiver, and primary user can also directly transmit to the receiver. So there is a certain network where primary and secondary users will transmit. Okay, so that is basically spectrum sensing structure of the cognitive radio system. Cognitive radios will only transmit when primary user is ideal. Cognitive radio will only transmit through the link when primary user is ideal. Okay, when primary user is transmitting, cognitive radios will not transmit. But yes, cognitive radio can use the same spectral system, same nodes, architecture, same paths from primary to receiver for the transmission, but on the basis of spectrum sensing. Okay, now here is one example of the MATLAB code taken here. Now you can see here there are the 5 channels. Channel 1, okay, you have already seen the amplitude modulated system. So these are the amplitude modulated system for the first spectrum, amplitude modulated of second channel. Third channel and fourth channel are vacant here. For channel 3 and channel 4 are vacant here, and this is your, the last one is your, that is your channel number 5. So here you can see that I can identify based on the spectral density, I can identify the channel number 3 and channel number 4 are the vacant. So I can use them for the cognitive radio systems. Hope this particular lecture was pretty useful for you all. So stay safe. Thank you. And before going through this lecture, I suggest you